Welcome to the College Algebra Lesson 26 activities. We have a bunch of rational functions to graph, so let's get to it. Okay, first step is to identify the domain, which would be the set of all x's such that x is not 0 or -4. Those are the x values that would make that denominator 0. Next, you factor everything and cancel. If you cancel, there might be a hole. If you don't cancel, we've got no holes, because nothing cancels there. 3 is vertical asymptotes. Those happen any place where the denominator is 0. So at x equals 0 and x equals -4. 4, horizontal asymptotes. Those occur when you look at the ratio of the numerator and the denominator. So this would be x plus 1 over x squared plus 4x. And if we were plugging in really, really large values of x, like a million squared is so much bigger than a million that I could say this is approximately equal to x over x squared, right? That I can drop the 1 off and I can drop the 4x off, which is 1 over x, which goes to 0. So my horizontal asymptote is at y equals 0. X and y intercepts. So x-intercepts happen when the numerator equals 0. So x-intercepts happen when the numerator equals 0, so that's x equals -1. Y-intercepts happen when you plug 0 in. R of 0 would be undefined, right? 0 is not part of the domain. So there's no y-intercept. And then last thing we need is some points. Okay, but I'm going to graph the stuff that I know first, and then we'll get some points that will help us. Okay, vertical asymptotes at 0 and -4. Vertical asymptote at 0 and -4. Horizontal asymptote at 0. Okay, then if x equals -1 is my x-intercept. So right here. And then I need some points. I need something in each region. So I need something to the left of this vertical asymptote. I need something over here. I need an x value between the asymptote and the x-intercept, between the x-intercept and the next asymptote, and then something in this big region over here. So let's see, points. I'm going to do x, y, and I want something to the left of -4, maybe -5. Something between -4 and -1, maybe -2. Something between -1 and 0, maybe -0.5. And something bigger than 0, maybe 1. And I'm going to plug all those x values into my function and see what I get for y values. Okay, so a quick way to do this is to type your function into y1. So it was x plus 1 over x times x plus 4. X plus 1 over x times x plus 4. Go to my table, type in the x's I want, -5, -2, -0.5, and 1. So I have -5, -8, -8, a quarter, -0.2857. And 0.4. Okay, so I've got -5, -8, it's right there, and -2, a quarter, right there, and -0.5, -0.3-ish, something right there, and 1.4. Okay, so this one must go like this, up towards the horizontal and down towards the vertical asymptote. In between my two vertical asymptotes, it looks like one side goes up and the other side goes down towards the asymptotes. And then this point right here must approach this asymptote and this asymptote. All right, number 2. Step 1 is look at the domain. The set of all x's such that, let's see, what would I have to plug in to make 0? I think -2. If x were -2, then I would have 0 in the denominator. So set of all x's such that x does not equal -2, my domain. All right, step 2, factor and cancel everything. So I have 3 times x plus 1 over 2 times x plus 2. Nothing cancels, so I have no holes. Step 3, vertical asymptotes. Those happen when the denominator equals 0, so that would be when x is -2. 4, horizontal asymptote. The degree of the numerator and the degree of the denominator are the same, which means my horizontal asymptote is at the ratio of the leading coefficients, 3 over 2. X-intercepts and y-intercepts. So x-intercepts happen when the numerator equals 0, so that happens when x is -1. And y-intercepts happen when you plug a 0 in. F of 0 would be 3/4. And then 6, we plot some points after we draw everything else in here. So -2, horizontal asymptote at 1.5. Okay. X equals -2 is my vertical. Y equals 1.5 is my horizontal. I had an x-intercept at -1 and a y-intercept at 3/4, 0,3/4, which is about right there. Okay, so the region to the right of my vertical asymptote looks clear, like it goes like this. And then it looks like I just need one more point to the left of my vertical asymptote, and I'll be able to draw the rest of my graph. So maybe I just need something to the left of -2, like -3. Plug that into my function. 3x plus 3 over 2x plus 4. I want to plug in a -3. So 3 times -3 plus 3 over 2 times -3 plus 4 is 3. So -3, 3 is a point on my graph. Scroll down and plot the point -3, 3 right there, which means I can now approach my two asymptotes, and it's done. Okay, 6 over x squared minus x minus 6. 1, look at the domain. So any x value that would make the denominator 0 has to be excluded. So I might factor this. X minus 3 times x plus 2 is the denominator. Yeah. So x equals 3 and -2 have to be excluded. So that's my domain. The set of all x's such that x is not 3 or -2. 2 is to factor everything and cancel if possible. So I have 6 over x minus 3 times x plus 2. Nothing cancels, so I have no holes. 3, vertical asymptotes. Those happen when the denominator equals 0. So this is x equals 3 and -2. 4, horizontal asymptotes. Compare the degree of the numerator and the denominator. The degree of the numerator is less than that of the denominator, which means that my asymptote is at 0, y equals 0. X-intercept and y-intercept. There's no x, because x-intercepts happen when the numerator is 0 and the numerator is 6, so that can never happen. And then y-intercept happens when you plug a 0 in, so that would be at -1. 6 over -6 is -1. And then lastly, we just need some points. X and 6 over x squared minus x minus 6. And I'll get the points after I draw in what I already know. So vertical asymptotes at 3 and -2. And then I have a horizontal asymptote at 0. What else do I know? No x-intercept. I know there's a y-intercept, 0, -1. Plot that. 0, -1. And then I need some points. So I need something to the left of my first asymptote. So maybe I'll plug in -3. And then something between the asymptote and the y-intercept, maybe -1. Something between my y-intercept and the next asymptote, maybe +1. And then something after my second vertical asymptote, 4. All right, I'll have my calculator do these values for me. -3, -1, 1, and 4. 1, -1.5, -1, 1. Okay, and I just plot those points. -3, 1. -1, -1.5. 1, -1. And 4, 1. Okay, I added one more point here, 2, -1.5, because my value at 0 and at 1 were the same, so I wasn't quite sure if my graph would go up or down from there. So I plotted also 2, -1.5, so that it does look like it goes down. So this looks like something like this. And then over here, we approach these asymptotes like that, and like that. All right, I'm jumping over 4, 5, and 6, and I'm jumping right to number 7. Not going to do all of them for you because this is a really long activity. So in number 7, there's something different happens, so I'm going to make sure we do that one together. So step 1, identify the domain, right? And your domain is all x values except any that might make the denominator 0. So I set the denominator to 0. That factors to x plus 2, x plus 1. So x can't be -2 or -1. So set of all x's such that x is not -2 or -1. There's my domain. Step 2, factor everything and cancel if possible. So I have 2 times x squared plus 5x plus 6 over this denominator. I know factors x plus 2, x plus 1, And then this factors even more, 2 times x plus 3, x plus 2 over x plus 2, x plus 1. The x plus 2's cancel. So I have a factor on the top and the bottom, an x value that would make the numerator and denominator both 0, x equals -2. So I have a whole at x equals -2. To find the y value of that whole, I'm going to take the -2 value and plug it into my reduced function after I've canceled out the problem, right? Can't put -2 in because I'd get 0 over 0. But now that I've canceled the x plus 2, if I plug -2 in, I have 2 times -2 plus 3 over -2 plus 1. So that's 2 over -1, -2. So my whole is at -2, -2. So there's my whole. Now, once you factored and cancel, this is now what you use to answer the rest of the pieces of your graph. Vertical asymptotes, horizontal asymptotes, etc. Okay. So step 3, vertical asymptotes. Those happen where the denominator is 0, but not at the whole, right? So once we took out the whole by canceling here, and then my vertical asymptote would happen at x equals -1. My horizontal asymptote, compare the numerator and denominator degrees. They're both degree 1, so my horizontal asymptote is y equals the ratio of the leading coefficients, y equals 2. 5 is x and y intercepts. X-intercepts happen when the numerator is 0 of the reduced function, so that happens at x equals -3. And y-intercepts happen when you plug 0 in. So if I put 0 in, I get y equals 6 over 1, so y equals 6. So let's plot what I know so far. The vertical asymptote at -1, horizontal asymptote at 2, -1, oops. Horizontal asymptote at 2. I have a whole at -2, -2. And what else do I know? I have an x-intercept at -3 and a y-intercept at 6. X-intercept at -3, y-intercept of 6. That looks like enough to sketch this graph. Just connect those points and use the asymptotes as a guide. There we go. So we did one with a whole. We did 4 of the 9 rational functions. I'm going to leave the last half of them for you to do on your own. You do have the answers on the next page of the packet, so you can be sure that you get them all right.